So today I'm going to discuss about what is CPU scheduling. So these are the contents of CPU scheduling. First is introduction, types of scheduling, what are the scheduling criteria, and then there will be some scheduling times. Then first come first serve. These are the algorithms: FCFS, shortest job next, shortest job first, remaining, priority scheduling. This then round robin. And these are some advanced level algorithms that are multi-level queue scheduling, multi-level feedback queue scheduling, and the comparison of algorithms. Next, what is CPU scheduling? So, see this. These are the main two functions where CPU scheduling is used. That is, it determines the order in which processes access the CPU for execution. And to ensure the efficiency of CPU utilization, then minimization of response time, waiting time, and maximize the throughput. Next, what are the types of scheduling we have in CPU, in OS? So types of scheduling that are in OS, one is primitive scheduling, another one is non-primitive scheduling. So what is primitive scheduling? Primitive scheduling, it is a running process that can be interrupted to give the CPU to another process with a higher priority. So in which the arrival time is the first and which whose priority is at the most, that time the running process will give that process priority. Suppose for an example round robin, it is RR, it is a primitive because processes are interrupted after time quantum. Time quantum that can be derived as time slices. It can be 2 millisecond, it can be 3 millisecond, it can be 4 millisecond. That is time quantum. That will be explained in the next slides. And next is non-preemptive. Non-preemptive, once a process starts its execution, it cannot be interrupted. So for an example is FCFS, first come first serve. Another one is there, that is SJF, shortest job first, that is also a non-preemptive scheduling. We'll discuss later in the next slides. Now, what are the scheduling criteria? Means what are the criterias where scheduling work? First is CPU utilization. CPU utilization, throughput, turnaround time, waiting time, and response time. So, what is CPU utilization? The amount of time the CPU is busy, means high the utilization of CPU, that will be better. Throughput means number of processes completed per unit time. Turnaround time means the total time taken from submission to completion of a process, means from which time the process has been arrived from that to in which time the process has been completed. That is only the turnaround time. Waiting time, time a process spends waiting in the ready queue, means there is in the process, in case of process, in case of OS, we are having some waiting time, that is in which time the process has been waiting for a long time, that is there in the ready queue. From the ready queue, the process is coming in the final step. Then what are the response time? Time from submission until the process starts its execution. Now we'll see what are the scheduling times. These are the some points that you have to remember when you are doing some algorithms. In the algorithms, we need this basic things. One is arrival time, that is AT, the time at which a process enters the ready queue and becomes eligible for CPU schedule, that is the arrival time. Burst time, BT, the total time required by a process to execute on the CPU, also called CPU time. So burst time is also known as CPU time. Then completion time, the time at which a process finishes its execution. Means the process is finishing its execution, that is the completion time. Then turnaround time. The turnaround time is the total time taken by a process from arrival to completion. So here you can see You are having arrival time. Now you are having the completion time. So from that you are getting the turnaround time. So TAT is equals to CT minus AT. So this formulas will be required in doing the algorithms, which you will see in the next slides. Next is the waiting time. Waiting time, the total time a process spends waiting in the ready queue before getting CPU access. So what is the formula of this waiting time? Waiting time means turnaround time, which you have read earlier in the previous slide, TAT minus BT, which also have seen in the previous slide. Then response time is RT, the time from a process arrival in the ready queue to the first execution on the CPU. So, response time formula is the first execution time. The process is doing its first execution. That time you will require. That time minus arrival time is your response time. Okay. So now we will focus on the algorithms part. So first is first come first served, FCFS. So FCFS means it is a simplest CPU schedule algorithm. Processes are executed in the order they arrive in the ready queue. So you can learn from this very easily that when the process are coming in that order only they are in the ready queue. So it is an example of non-preemptive as I have discussed earlier. Once the process starts, it runs to completion. The execution order depends solely on the arrival time. So now you can see an example of FCFS. This is a algorithm. This is an example of FCFS. First, this will be given to you. So process, there are three processes, P1, P2, P3, and the given is arrival time is millisecond 0, 1, 2. The process 1 has been arrived in 0 millisecond. The process P2 has been arrived in 1 millisecond. The process P3 is also arrived in 2 millisecond. The burst time is 5, 3, 8. Okay. So now see this is a Gantt chart. We call this block diagram as a Gantt chart. Gantt chart means it is a visualization in which the execution of the process from arrival to execution. You can see in this Gantt chart means in which at which time the process is being executed and the process is being completed. So P1 arrives first, so it is executed first as it is FCFS. Then P2 arrives next, so it is executed after P1 finishes. Then F3 is executed last. So how the 0, 5, 8, 16 has come, you will see this. So this is how you have to calculate the times, this turnaround time and the waiting time. How? See this. So process you have given and the completion time is 8 6 a 5 8 16 as shown in the earlier slides. Then turnaround time means how you are getting the turnaround time, completion time minus arrival time. So completion time of P1 is 5 and the arrival time you can see in the previous slide is 0. So from this way, 5 minus 0 is equals to 5. Next, 8 minus 1 is equals to 7. Like this, 16 minus 2 is equals to 14. And the waiting time formula is turnaround time minus burst time. So from this, you are getting the turnaround time at first and the burst time you got in the previous slide. That is for P process 1, you are having 5, then P2 for 3, then P3 for 8. So like this, you are getting the waiting time. And then how you can calculate the average turnaround time? That is 5 plus 7 plus 14 divided by 3. That is the average. Okay, you know that how to get the average value. So like this, you are getting the average turnaround time and the average waiting time. So for this example, you are getting 8.67 average turnaround time and the average waiting time is 3.33 millisecond. Now next we are going for shortest job first scheduling SJF. So this SJF selects the process with the shortest burst time for execution. So there are two types of variants. One is non-preemptive SJF, another one is preemptive SJF. Non-preemptive SJF, once a process starts its execution, it cannot be interrupted. Okay, because the name suggesting is non-preemptive. Preemptive, there is one kind of SJF in preemptive, that is shortest remaining time first, SRTF. Also, we can tell as preemptive SJF. The CPU switches to a new process if its burst time is shorter than the remaining time of the currently executing process. So, optimal in minimizing average waiting time but may cause starvation for longer process. So, this is one optimal case for this SJF. Now, there is an example for non-preemptive SJF. You are given the four processes, then arrival time 0, 1, 2, 3, burst time like this. Now, how you will calculate non-preemptive SJF? So, look into this. First, you will form a Gantt chart. Gantt chart of P1, you can see at time 0, P1 arrives and is executed since it is the only process in the queue. At time 6, P2, P3, P4 are in the queue, but P4 is selected because it has the shortest burst time, that is 3 millisecond. Say this. So P4 is having the small burst time, that is 3. For this, P4 came at fast. Then after P4, the remaining processes are P3, that is 7 millisecond, and P2 is 8 millisecond. P3 is selected next, and finally P2 is executed. So in this SJF, we are focusing on the burst time, in which if the arrival time is there, matlab, if the arrival time is from 0 to 3, you can see in this, but in process P2 you are getting more burst time, that is why P4 came first. So that is the main thing of this algorithm, that is SJ. Now these are the calculating how you can calculate. Similar way you have to calculate completion time is you are getting from the Gantt chart. Then turnaround time you will write like this way. Then waiting time you will calculate like this. Then average turnaround time you have to average, because there are four processes, so you have to divide it by 4. And then average time is average waiting time. Now we will learn what is shortest remaining time for scheduling, or we can tell it as preemptive SJF. Okay, so as SRTF is the primitive version of shortest job first. In SRTF, the process with the shortest remaining burst time is selected for execution. So what is the primitive behavior? If a new process arrives with a shorter burst time, then the remaining time of the currently executing process, the CPU switches to the new process. Okay. So this is an example of SRTF. So there are four processes: arrival time and then the burst time. So you can see the gadget again. Now, what is there? What difference you are getting to see? Previous in the non-preemptive SJ and this preemptive SJ. You can see that P1 has arrived 2 times. So there is an preemption. So there is an interrupt. So at time 0, P1 arrives and starts execution since it is the only process. Okay. Then at time 1, P2 arrives with a shorter burst time, that is 4 millisecond, and that time P1 is preemptive. Preemptive, and P2 starts executing. At time 3, P4 arrives with a burst time of 5 millisecond. P2 continues since it still has the shortest remaining time, in which the burst time, here is the only algorithm you have to see, that whenever the burst time is less from the previous one, then you have to find that burst time and you have to put in the Gantt chart first, then it will come later on. So like this way, at time 5, P2 finishes, then again P4, then at time 8, P1 resumes since it has the shortest remaining time. Then at time 14, P1 finishes and P3 just starts execution after at time T3, P3 finishes its execution. So these are the that how this process is taking place, means how the execution is taking place, you can see by reading this thing. Now calculation is very much similar from the previous one. So you are getting the completion time. When you are getting the completion time, then it is very easy to find out turnaround time and waiting time. So then, so this is average turnaround time, means the four processes are there. You have to average it. Then again, average waiting time you have to, again you have to average by four. So these are the basic things. Now, what is round robin? Round robin, it is a primitive CPU scheduling algorithm where each process gets a fixed time quantum to execute after using its allotted time quantum. A process is moved to the end of the ready queue if it is not yet complete. The CPU cycles through all processes in the queue in a circular manner. So now the time quantum is given, suppose 2 milliseconds. This is an example. So I am given of time quantum is 2 milliseconds. So there are four processes. How this 2 millisecond is working on. Let's see. So this is your Gantt chart. So how this 2 millisecond is counting? Say this from P1 to P2. So P1 was 0. From P1 is having 5 burst time. P2 is having 3 burst time. So 2 millisecond will be added in burst time. Suppose 0 plus 2. That will be 2. Then again, then 2 plus 2, 4. Like this way, it will be counted. If the burst time, suppose if there was a burst time of 1, then you have to add only 1 millisecond because you don't have another 2. Okay, so how much the burst time is there, from that only you will subtract 2 millisecond. So at time 0, P1 starts execution for 2 millisecond time quantum. It has 3 millisecond remaining as I have told earlier. Then at time 2, P2 executes for 2 millisecond. It has 1 millisecond remaining. After that at time P and time 4, time 6, the cycle repeats. P1 resumes execution for another 2 millisecond and so on. The process will be completed. Now, say this completion time is you can get from the Gantt chart, then turnaround time you have to calculate, then the waiting time and the form average turnaround time and average waiting time is similar like this. Now, what is priority scheduling? So, in priority scheduling, each process is assigned a priority value. The CPU selects the process with the highest priority for execution. So if two processes have the same priority, they are executed based on FCFS order. Means the priority level is same. If they are same, then it will be first come first served. And there are two variants, one primitive, non-primitive priority scheduling and primitive priority scheduling. Once the process starts, it runs to completion, and for primitive, it will be an interrupt, then switches to a higher priority process if it arrives, while a lower priority process is executing. Then there's an example of non-primitive priority. So priority is 1 equals to highest. That means P2 is having the highest priority. Then after that P1, then the priority is high P4 and at last the P3. So P3 is having the lowest priority. Now see, in the Gantt chart, processes are sorted based on priority. So P2 priority 1, then P1 priority 2, P4 priority 3, P3 priority 4. So order of execution at time 0, P1 arrives and starts its execution. At time 5, P2 starts execution because it has the highest priority. Then at time 8, P4 executes and at time 14, P3 executes. So this is the calculation for the times turnaround time. You are getting the turnaround time from the completion time and arrival time. And next you can see that average turnaround time and average waiting time. So this is the comparison table. First you are having four algorithms: FCFS, SJF, round robin and priority. So in primitive, FCFS is having no preemption. In SJF, it is having both because I have told earlier that there is a two, that one is SJF, another one is SRTF. So that is only an primitive SJF. Then round robin is also primitive. Then priority also it is having both two, non-primitive and primitive. Then highest waiting time for FCFS is high, for SJF is low. Then round robin is medium, and for priority it varies because if the priority is uh, 2 or if it is 3, then in that case it will vary. And starvation for FCFS, there is no starvation. For SJF, there is having SJF. In round robin, no, there is no. Then priority, it is having a starvation. Then these are the fairness and overhead. So these are the main things. These are the algorithms that I have discussed today. So thank you.